Now let's take a look at chemical weathering. We'll start with the liquid that's the main cause of chemical weathering on the Earth: water.
Huh? Water? But water is the basis for life on Earth. How could it be destructive?
Water will dissolve more things than any other substance on Earth, even though it sometimes takes a very long time.
It will even dissolve rocks?
Water will dissolve the minerals that hold some rocks together. When this happens, the rocks begin to crumble. Look at these odd rock formations. They were formed because the rocks that capped them didn't dissolve in rainwater as fast as the rocks that made up the pillars. As the rain slowly dissolved away all the surrounding rock, the cap rocks acted like umbrellas, sheltering the pillars below them.
Those are some heavy umbrellas.
Over many years, exposure to the weather can damage the marble rock used in sculptures. Look at this old statue and these tombstones.
Those tombstones will soon need their own tombstones.
Water can also combine with certain gases in the air to form acids. This is especially true in modern times when the pollution generated by burning fossil fuels releases large amounts of sulfur compounds into the air. Water vapor and rain combine with this chemical to form weak sulfuric acid. This is where the term acid rain comes from. Acid rain not only weathers rocks, it destroys man-made structures and kills forests and fish. Carbon dioxide is present in the air in large amounts. When carbon dioxide combines with water, it forms carbonic acid. This is called carbonation. This weak acid can still dissolve some minerals, especially calcium. It will dissolve limestone completely. This is how many underground caverns are formed. The limestone is literally dissolved away.
Are there any other kinds of acids that weather rocks?
Surprisingly, some plants create weak acids. Those crusty things often seen growing on rocks are called lichens. Lichens create weak acid, which causes chemical weathering, while the tiny roots of lichens break up rock surfaces through physical weathering. Let's see if you can guess what the final agent of chemical weathering is. It's another one you probably wouldn't expect.
Well, the first one was simple water, so, I don't know. How about air?
Correct. The oxygen in air, to be exact. The oxygen often combines with minerals or elements in rocks and changes them into other compounds, which weaken the original rock. This is called oxidation. One of the most common of these reactions happens when iron combines with oxygen to form reddish iron oxide, known as rust, which you see in the red rocks here.
5 forces of physical weathering. And now, 5 causes of chemical weathering. Water, sulfuric acid, carbonation, plant acids, and oxidation.
And remember, chemical and physical weathering are often at work at the same time.
When physical and chemical weathering combine, the results can be dramatic. These rocks owe their rounded shapes to the combined effects of physical and chemical weathering. You see, over thousands of years, ice has cracked these rocks again and again. When these cracks first form, their edges are jagged. But during these same thousands of years, a lot of rain has fallen on these rocks. And the weak carbonic acid in the rainwater has chemically dissolved the sharp edges away, giving the rocks their rounded form. Here's a well-known example of the combined forces of physical and chemical weathering. The physical weathering of blowing sand, combined with the chemical weathering caused by rain, have severely damaged the famous Sphinx in Egypt. You've seen the dramatic examples of physical and chemical weathering in nature, but you can see plenty of examples of how weathering affects man-made objects too. The oxidation of iron and steel, rust, is chemical weathering. The greenish coating on this old bell is formed by the oxidation of bronze. Stone statues and grave markers are slowly worn away by chemical weathering. Other man-made structures can be damaged by years of chemical weathering. Unprotected wood is quickly damaged by water. Scientists are continually developing new types of paint to protect wood and other materials from weathering. But paint is eventually weathered by the same forces it protects the wood from. The paint on automobiles is not only attacked by water and acids, but like the Sphinx, it can be damaged by blowing sand. As you can see, the forces of physical and chemical weathering are constantly at work on everything around us.